Due to climate change, the water balance is shifting. Heavier and longer periods of drought and rain lead to bigger differences in water levels. The River Rhine is the biggest source of fresh water for the Netherlands. Annually, it delivers more water than rain. The Rhine feeds most of our main rivers, so as you can imagine, it's very important to know how much water the Rhine is discharging into the Netherlands at any moment, as it affects practically all our rivers. The Rhine enters the Netherlands at Lobith on the border with Germany, so that's a logical point to measure the discharge. At Lobith, the river is more than 300 meters wide, and the difference between the lowest and higher water levels is almost 11 meters. That's a huge difference. The discharge can vary from less than 1,000 cubic meters per second to more than 12,000 cubic meters per second.
Our customer asked us to come up with a solution for continuously monitoring the discharge of the river. We decided to use an acoustic instrument called a horizontal acoustic current Doppler profiler, which will be mounted on a tall pole that will be placed in the riverbed. Our partner De Boer and De Groot will do the construction work, and we, Observator Instruments, will do the instrumentation part.
To measure such a large variance in discharge is challenging. Observator decided to conduct the measurements with an acoustic instrument, a horizontal acoustic Doppler current profiler. It emits supersonic sound pulses through the water. The water reflects part of these pulses back to the instrument. From the Doppler shift of these reflections, the instrument calculates the speed of the water and, from that, the discharge in cubic meters per second. Because the water level can change by 11 meters, we needed to place the horizontal acoustic Doppler current profiler on a large pole in the river. Because no electricity is available, we decided to use solar panels. For periods where there is insufficient sunlight, we added a small windmill to reduce the amount of batteries. In addition to measuring the discharge, we are also measuring the water level. For this, we use radar. The radar is mounted on top of the pole and looks down at the water, measuring the distance to the water surface. All the measured data is transmitted by GPRS to our and our client's internet server. With this data, we can constantly monitor the river as well as the proper functioning of our equipment.
The pole is now fully operational. It is continuously providing the discharge data to our customer, who is very satisfied with the high accuracy of the data. We, as Observator Instruments, are proud that we have contributed to the water management of the Netherlands.
In cooperation with the contractor De Boer and De Groot, we managed to deliver the results on time and to the full satisfaction of our client. Observator Instruments, your reliable partner for turnkey hydrological and meteorological projects.